guys, we're going to talk about parallel and perpendicular lines. This is lesson 5.2. So we've been talking about systems of equations. And when we have a system of equations, what that means is that we have just more than one equation on a graph that shows up as more than one line. Okay? And when we're looking at two different lines, and we're trying to find the solution of that system of equations, the solution is going to be that point of intersection where the two lines meet. But what happens if the lines don't intersect? Well, that is the case for parallel lines. So parallel lines look like this, and they never intersect. They never intersect. And kind of similar point, they are always the same distance from each other. They are always the same distance from one another. This distance here will always remain the same. So something else we've been talking a lot about is the slope of a line. The slope of a line. So the slope of two parallel lines is going to be the same, which I think just kind of intuitively should make sense. If this line and this line are parallel to each other, it's pretty clear that they have this same slope, the same rise over run, same rise over run. Okay, so the slopes are the same. Okay, so if the slope of this line is 1 over 2, then the slope of this line would be 1 over 2. Okay, and something else to point out about parallel lines is we denote parallel lines by drawing two little arrowheads, one on each line, like this. So just putting two triangles on the line. So if you ever see two lines with those two arrowheads on there, that's how you know that they are parallel, okay? And if you ever wanted to draw two lines and make it known that they were parallel, you could add those two lines on there, right? So parallel lines are the only example of lines that won't intersect. But some lines intersect in a special way, and that would be perpendicular lines. So perpendicular lines form a 90-degree angle, a 90-degree angle. And the slope of one perpendicular line compared to its counterpart would be, they are opposite reciprocals. So opposite meaning opposite signs, so one would be positive and one would be negative. And then reciprocal means it's a similar term to the multiplicative inverse, okay? So if the slope of one perpendicular line is 2/3, then the opposite reciprocal, would be -3/2, okay? So if one slope was 4, the opposite reciprocal would be -1/4. The slope is 1/2. The opposite reciprocal would be -2/1, which is just -2. Okay, we'll have a little bit more practice to work on that too. So perpendicular lines are denoted by a small box that connects the two lines together. So if you see two lines intersect and they have a small box like this, we know that those two lines are perpendicular and that their slopes will be opposite reciprocals, right? So again, when lines are parallel, they don't intersect. And so a system that has two equations which represent parallel lines will have no solution. Therefore, and this is just restating this in a different way, the solution for a system with parallel lines is the null set. Null set, kind of looks like an F, but it should be an S. The null set, which is denoted as this. So if I'm asking for the solution to a system of equations whose lines are parallel, the system would have no solution. The answer would be no solution. Okay? And then for perpendicular lines, which are, again, a special case of lines that intersect only at one point, in any system that represents lines that intersect at only one point has what we call a unique solution, And that's been most of the systems of equations we've been looking at, where two lines intersect and they intersect only at one place. That is called, again, a unique solution. And then there's a third type of system in which two equations would represent the same line. If that was the case, I know it looks like there's only one line here, but imagine there's two lines here. Imagine there's two here. If the equations represent the same line, then that system would have infinitely many solutions, infinitely many. And I talked about this a little bit, this idea of either no solution or infinitely many solutions before, but just want to reiterate that concept, okay? Let's do a practice problem. So we have this question, write an equation to model each line described. In part A, we're going to write an equation for a line that is parallel to y equals 3 minus 5x and passes through the point 1, 7. In the second one, we're going to write an equation for the line perpendicular to y equals 3 minus 5x and passes through that point 1, 7. So let's remember, parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. Okay, so let's work on this first one, part A. Okay, so for part A, we are finding the equation for the line parallel to y equals 3 minus 5x and passes through 1, 7. So I know that parallel lines have the same slope. So a line parallel to this line will have the same slope as this line. So let's write that down. Y equals 3 minus 5x. I'm going to ask you to find the slope of this line. Find the slope of this line. Pause the video and then come back. Yes, the slope of the line is -5. -5. Slope is, so that's the slope of this line. I'm looking for a line that's parallel to this and passes through 1, 7. So I'm going to start with just my intercept form, y equals a plus bx, right? This is my new line that I'm writing an equation for. I know the slope of that line. It's going to be -5 because it's parallel to this line, and this line has a slope of -5. So I'm going to replace my b with -5. So I get y equals a minus 5x, right? Now what I need to look for is this a. I need to look for my y-intercept. I can find my y-intercept by taking this point, that 1, 7, and plugging it in down here. Plugging it in. Where 1 is going to be 1 is going to be x, and 7 is going to be y. So I plug in 1 for x, 7 for y. And I get 7 equals a minus 5 times 1. Now I can solve for a. And remember, a is my y-intercept. So I'm going to solve for a. So first I need to do 7 equals a minus 5. 5 times 1 is 5. And now I want to get the a by itself, so I'm going to move this 5 over here to be with the 7. So I add 5 here, add 5 over here, and I get 12 equals a. So 12 is my y-intercept. Now I have my y-intercept and I have my slope, so I can write my equation. So my equation for a line that is parallel to y equals 3 minus 5x, passing through the point 1, 7, is going to be y equals 12 minus 5x. That's my answer. Great, let's try the second one where we're looking for a line that's perpendicular now, perpendicular to y equals 3 minus 5x, and passes through the line 1, 1, 7. So again, my slope of this line is -5. So think about it for a second. What is the opposite reciprocal of -5? What is the opposite reciprocal of -5? Pause the video, think about it, and then come back. Yes, the opposite reciprocal is 1 over 5. 1 over 5. So remember, -5 equals -5 over 1. And then we just invert and change the sides, change the sign. So if I invert, I'd get -1 over 5. And then changing the sign, it'd go from negative to positive. And so my opposite reciprocal is 1/5. So that is going to be the slope of the new line. So again, let's write our base, our template, y equals a plus bx. I know what my b is going to be. It's going to be 1/5. So y equals a plus 1/5 x. Okay. And now I take this point and I plug it in to the equation. X is going to be 1 and y is going to be 7. Right? I'll give you guys a minute. Pause the video. Try to solve for a. Solve for a. And then come back. Yeah, so I plug in 1 for x, 7 for y. So I get 7 equals a plus 1/5 times 1. Then I get 7 equals a plus 1/5 times 1 is just 1/5. It's just 1/5. And then if I need to get this 1/5 over here with the 7, I'm going to subtract 1/5 from here, which means I subtract 1/5 from there. These 1/5s cancel out, so I'm left with just a on one side. And then 7 minus 1/5. 7 minus 1/5. So if I write 7 as a fraction, it's 7 over 1 minus 1 over 5. Well, if I need to subtract fractions that have different denominators, my first step needs to be changing one of my fractions so that they have the same denominator. So this becomes 35 over 5 minus 1 over 5, which is 34 over 5. 34 over 5. That's my y-intercept. Another way to think about it, if I had 7 and I take away 1/5, 7 and I take away 1/5, well, that would leave me with 6 and 4/5. 6 and 4/5. That's the same thing. Okay, so think about it, just bear with me for a second. Think about it. If you had $7 and I said you take away 1/4, so if I said you had $7 and you took away a quarter, if I took away a quarter from you, you'd be left with 6.75, right? Well, that's 6 3/4. So if I had 7 and I took away 1/4, you'd be left with 6 3/4. Okay. So same thing over here. It's 6 4/5. So my answer here, or my y-intercept here, is 34 over 5, or 6 4/5. And so my answer will be y equals 34 over 35 plus 1 over 5x. Right? So I have a couple practice problems for you that are like this in the Google form for today. I want you to give those a try. And if you have questions, as always, please reach out, email me, call, text, leave a comment in the Google Classroom. I am here to help, happy to help. Right? Hope you guys are having an awesome day, and I hope to hear from you soon.